Okay, I'm back. We're going to do base ionization constants now. These aren't used by the IB quite as much, and there's not really much difference with these as with what we were just doing. There's just one small little quirk in using the pH-POH relationship. I'm on page 233 of your notes, and we'll just start right in with the examples. So it says a new drug, I got these from some other author, a new drug obtained from seeds of a strange Colombian plant was found to be a weak organic base. A 0.1 molar solution in water of this drug had a pH of 10.80. What's the Kb for the drug? Okay, using what we have been using before, let's just call this, I don't know, let's just call it drug plus water. Now remember, this is now a base, so it's going to take hydrogen from water, hydrogen ion from water, so let's call that H drug plus and OH minus. My Kb will be the concentration of H drug plus times the concentration of OH minus, and we're going to just flip that and or put a line there, and then we'll put that all over drug. Okay, are you with me? Let's go down over here and get our table together, as you know how to do this, hopefully. H drug plus and OH minus, initial, change, and final. So we have 0.100, 0, and 0. I'm a little out of alignment there, but now what are we going to do here? Well, notice that we have a pH of 10.80. We need the concentration of OH minus. So there's a number of different ways that we could do this. I might just go back up here to the top of the page. I'm running out of a room here, but our pH is 10.80. So the pOH will equal 14 minus 10.80, which is equal to 3.20. And if we want to calculate our OH minus concentration, that will be 10 to the minus pOH, which is 10 to the minus 3.20. And I'm running out of room again, but I think that's equal to 6.3 times 10 to the minus 4 molar. So let's go back to our table. I have 6.3 times 10 to the minus 4 and 6.3 times 10 to the minus 4, because these are in a 1-to-1 ratio. And then that's going to be a positive here and here. And obviously it's negative here, so 6.3 times 10 to the minus 4. And I think that we'll round it off, will be 0.099. Again, we have some significant figure issues when we're subtracting. Okay, so let's go plug all our numbers in. So we have 6.3 times 10 to the minus 4, that's squared, over 0.099. And if we calculate all that out, 6.3 squared, that's suspiciously like 40, pretty close to 40 times 10 to the 8, so 4 times 10 to the minus 7, and then divide by 0.01 roughly. So I think it'd be 4.0 times 10 to the minus 6. And there's our answer. Okay. Now, very quickly, let's go on to the second problem here. We were talking about caffeine. It's a weak base related to ammonia. Can you imagine? With all the coffee I drink, I still drink it, even knowing that. For the purpose of the example, we'll just use caffeine. It has a base ionization constant of 4.1 times 10 to the minus 4. Calculate the pH of a 0.7 molar solution. Okay, so again, caffeine plus water. Put in our equilibrium sign. We're going to get H caffeine plus OH minus. Do our Kb. Could anything be simpler? A table. initial, our change, our final, 0.7000. Again, this time we have to use x's, unknowns. So again, you've done numerous problems like this. Maybe you see where this one's going. So we've got a 4.1 times 10 to the minus 4 equals x squared over 0.70 minus x. Again, it's going to lead to a quadratic, not a big problem in this day and age of computers, but let's see if we can get rid of that. Take the value that x is added to or subtracted from, so I'll do that down here, 0.70, divide by 4.1 times 10 to the minus 4, and I think we get around 1700. Therefore, we can say that 0.7 minus x approximates 0.7. Again, I want to see that in your question, so let's just say this goes to 0. 0.7 of 4.1 is, let's just call it 2.8 times 10 to the minus 4 equals x squared. X must equal, well, the square root of 2.8 is going to be, I'm not really sure, but if we were to calculate it, I think it's about 1.6 times 10 to the minus 2. However, that's not what we're looking for. We're looking for the pH. It's probably much easier now that we have the OH concentration to find pOH. Okay. And if we have the pOH, it's going to be minus the log of 1.6 times 10 to the minus 2. And if I work that out, it's 1.77. Not hard to believe with a times 10 to the minus 2. So my pH will equal 14 minus my pOH, which is what now? 12.23. And there's my value. Okay? Once again, there's some problems on the next page for you to do for homework. Please try to have those done for next day. And I'll see you when I get back from my trip.